Hi everyone, and welcome to another episode of Chemistry with Capadia. Today I will be doing a tutorial on how to find the empirical formula of hydrates. If you're looking for how to find the empirical formula of regular compounds, then you can go to the empirical formulas video. Okay, so a hydrate is a compound that contains a certain number of water molecules. So we are going to find the formula of a hydrate using the same steps that we use for finding the empirical formula. Percent to mass, mass to moles, divide by small, but then we don't ever need to multiply by whole because we are only ever going to have a ratio of 1 mole of compound to some number of moles of water. So we don't need to do this step here. We're just going to divide by small and then we're done. So this is actually a little bit easier because we do not have to worry about multiplying. Percent to mass, mass to moles, divide by small. So it's not a rhyme anymore, it's like a haiku, except for not. Anyway, now sometimes we're not given the percentages, so we can't just do percent to mass. So if we're not given percentages, then what we need to do is we need to find the amount of anhydrous compound and the amount of water. When we have a hydrate, we have the hydrated mass or the hydrated compound that already has water in it. And if we subtract that mass from the compound with no water in it, that will give us the mass of the water. If we have the water mass and we have the hydrate mass, then we do hydrate minus water to get anhydrous. So essentially, you can do whatever form of this formula you need in order to find what you're missing. But when we do the math that we use for the compound has to be the anhydrous mass. It can't have water in it because if it has water in it, then we're doing double. We're taking into account the mass of the water in the compound, and we're doing it when we do the mass of the water. So when we put it into the formula, it can only be the anhydrous compound mass and then the mass of the water. The only reason we need the hydrate mass is to figure out the mass of the water. Okay, so let's do some examples. If we look at this, it says a hydrate contains 48.8% MgSO4. What is the formula for this hydrate? So every hydrate contains compound and water. So if I know the amount of compound, I can figure out the amount of water because the percent always has to equal 100. So when I do that math, I get 51.2% water. So I know that my magnesium sulfate, MgSO4, is going to be 48.8%. So I do percent to mass, so that means it's just 48.8 grams. The water I just figured out is 51.2%, which means that it is 51.2 grams. Okay, so now I'm going to do mass to moles. So to do that, I'm going to need the molar mass of MgSO4. All right, so to find the molar mass of MgSO4, I go to the periodic table. I do the mass of magnesium plus the mass of the sulfur plus 4 times the mass of the oxygen. If you're having trouble figuring out the molar mass, then there's a video on that, and so you should watch the molar mass video. Here, we're not going to get into the details of how to find molar mass, but we're going to say that we calculated it, and we got that the molar mass of MgSO4 is 120.36 grams, and that is equivalent to 1 mole. Molar mass of water is the mass of both hydrogens plus the oxygen, and that is going to be 18.02 grams. And then I have 1 mole on top. Grams cancel with grams, and I'm left with moles of each of my substances. All right, so I'm going to do 48.8 divided by 120.36, and I get 0.45 moles of MgSO4. So since I am using these values to figure out the formula, I like to use as many decimal places as I can during my calculations to get the most accurate value. So when I do this, I like to have at least 3 significant figures behind my decimal place. So here I'm going to round to 3 digits behind the decimal so that I have enough figures to where I get a good answer. If you don't use enough figures, especially with hydrates, then when you do this, you will end up getting answers that are incorrect. So it's important not to round. And then 51.2 divided by 18.02 is going to be 2.841 moles of H2O. So we did percent to mass, mass to moles, and now we divide by small. And then this is all that we need to do Here, we're not going to do the multiply till whole part because you should always get 1 for your compound. So we have 1 MgSO4, and then you'll always get a whole number here. So 2.841 divided by 0.405 is going to give me 7 H2O. So that means that my formula of my hydrate is going to be MgSO4, and then I put a dot here for multiplication, and then 7 H2O. So that means that for every 1 mole of compound, I have 7 moles of water. So for every 1 formula unit of MgSO4, there are 7 molecules of water attached to it. Okay, so let's do another. Here, this says that gypsum is a hydrated calcium sulfate, CaSO4. So we heat 4.89 grams of gypsum to remove the water, and we get 3.87 grams of anhydrous compound remaining. Determine the formula of this hydrate. Okay, here I'm not given percentages, which means that I can just use mass. So I'm going to need the mass of the anhydrous compound, the compound without water, and I'm going to need the mass of the water. So here I know that the anhydrous mass is 3.87, but I don't know the mass of the water. What I do know is the original hydrate mass. So if I have 4.89 grams of hydrate and only 3.87 grams of that is anhydride, meaning no water, that means that the mass that was lost is going to be the mass of the water. So I have 3.87 grams of compound and 1.02 grams of water. So that's what I'm going to use to find the formula of my hydrate. So CaSO4, I have 3.87 grams, and the water, I have 1.02 grams. So now I'm going to divide by the molar mass to get to moles. So the molar mass of calcium sulfate is 136.14 grams, and the molar mass of water doesn't change, so it's the same as the last problem, 18.02 grams. All right, and so here I get 0.0284 moles CaSO4. And I said last time that I was going to round to 3 significant figures behind the decimal place. So this 0 here is just a placeholder 0. It's not significant, which is why I rounded to 4 digits behind the decimal instead of 3 this time. Like I said, the more digits that you have, the more accurate your answer will be. All right? So when I do this math, I get 0.0566 moles of H2O. All right, so now I divide by small. Your small is always going to be the compound, because you can only have 1 mole of compound for every however many waters. So you get 1 CaSO4, and then 0.0566 divided by 0.0284 is going to be 2 H2O. So the formula of my hydrate is going to be CaSO4 dot 2 H2O. All right, let's do one more. The only time that this gets any more complicated is if we're just given percentages of everything. So this says that an anhydrous sample of compound contains 36.4% sodium, 25.43% sulfur, and 38.08% oxygen. And then it says the hydrate of this compound contains 36.4% water. Okay, so what is the empirical formula of the anhydrous compound? So here we go back to our rules for finding empirical formula, and we use those to figure out the empirical formula. Once we have the empirical formula, then I can find the hydrate formula. So I have 3 elements. I have sodium, I have sulfur, and I have oxygen. This percent of water I'm not going to worry about right now because that's not part of my compound. That's part of my hydrate. So I'm just going to look for the anhydrous compound first. So I have 36.49%, which means I have 36.49 grams of Na, 25.43 grams of sulfur, and 38.08 grams of oxygen. And then I'm going to divide by the molar mass of each. So I find the molar mass of sodium, molar mass of sulfur, and molar mass of oxygen. All right, and then when we do that math, we get 1.587 moles of Na. We get 0.793 moles of sulfur, and we get 2.380 moles of oxygen. Okay, now I divide by small, so the smallest one is 0.793, so I divide everything by 0.793, and for sodium I get 2, for sulfur I get 1, and for oxygen I get 3. So that means that my formula for my anhydrous compound is Na2SO3. Okay, so that gives me the anhydrous compound. So now I need to find the hydrated formula. So here I am going to now pay attention to this water. So if 36.4% is water, then if I subtract that from 100, I get 63.4% is going to be Na2SO3. So now I know I have SO3 and I have H2O. So 63.4% is 63.4 grams of Na2SO3, and 36.4% is 36.4 grams of water. Now I do mass to moles, so I divide by the molar mass. Molar mass of Na2SO3 is 126.03 grams. And the molar mass of water, as per usual, is 18.02 grams. Okay, so when we do this math, I get 0.505 moles of Na2SO3, and I get 2.020 moles H2O. All right, now I divide by small, so I do 0.505 and 0.505. So here I get 1 Na2SO3, and here I get 4 H2O. So the formula of my hydrate is going to be Na2SO3 dot 4 H2O. Hooray and huzzah. Okay, so that is really as complicated as it gets for solving for hydrates. All right. This has been another episode of Chemistry with Capadia Tutorial Edition. I hope you learned something, and until next time, keep on chemin'.